So we said there are some calculations we can make from chemical equations. Number one was the number of moles of either reactants and product. We've done that part. Number two was the mass of reactants and products. It's quite easy. The only concept is if they give you mass, know when to change to mole. If you have mole, they ask for mass, know how to do the conversion. No big deal there. The other calculation involves number one, limiting and excess reagent. Note that the term reagent can be used interchangeably with reactant. Yeah? So you can call this limiting reactant and what there? Excess reactant. Same thing. Take down, please. What's a limiting reactant? What's an excess reactant? It's easy to define. The term will tell you limiting reactant. The reactant that is limited. Excess reagent. The reagent that is excess. Take down, please. Limiting reagent is the substance that is used up first in a chemical reaction. So that's it. While the remaining part of the reactant in such situation are called excess reagents. While the remaining in bracket unreacted parts of the reactants in such situation are called excess reagent. So what's the difference? If I have a chemical reaction involving reactants, in some cases you have that, let's say I'm reacting A and B. So A and B react to form C. In some cases, if I'm reacting A and B, it's get to a point where it's get to a point where B will be finished. By the time one reactant is finished, the chemical reaction will stop. Although I might still have some substance of A still left. So the one that finishes first is called what there? Limiting reagent. The one still remaining is called what there? Excess reagent. That's all. All right. Number two. Theoritical, actual, and percentage yield. Theoritical, actual, and percentage yield. Let's define them. Okay, you can add here of products. You can add there of products. Please note that when it comes to the concept of limiting and excess, listen, there is no limiting product in quotes. Limiting and excess only works for reactants. When it comes to theoretical, actual, and percentage is for product. There is no theoretical product, no. All right, so this is for reactants. This will solve problems on two of them. That's how it works. Please take that, please. Let's define them. The theoretical yield of products is the maximum amount of products that can be obtained by the reaction from given amount of reactants. The theoretical yield of products is the maximum amount of products that can be obtained by the reaction from given amount of reactants. That's it. The maximum amount of products that can be obtained from a given amount of reactants is called theoretical yield. Next up, this man, actual yield. Actual yield is the amount of specified pure products the amount of specified pure products that is actually obtained, the amount of specified pure products that is actually obtained from a given reaction. Actually obtained from a given reaction. We'll stop. Finally, let's define theoretical yield. Percentage yield. Finally, let's define percentage yield. Please take that, please. Percentage yield is 100% times the actual yield divided by theoretical yield. 100% times the actual yield divided by the theoretical yield. This definition is too mechanical. So copy this, let me give you a proper definition. Times the actual yield divided by theoretical yield. Here is free now. Why don't you use here instead? Here, this one here is free. What's it? Welcome to engineering. All right. Let's use a proper definition, please. Take down, please. Percentage yield. Percentage yield is the ratio of actual yield to theoretical yield expressed as a percentage. The ratio of actual yield to theoretical yield expressed as a percentage. Mathematically, we're saying that percentage yield of products is equal to actual yield all over theoretical yield expressed as a percentage becomes times 100%. So that's it. That's the formula, please. All right, we'll just do one or two questions here. Then we can now go straight to past questions. So let's take this example on percentage yield, actual yield, theoretical yield. Question says, a 0.443 gram sample of silver metal is obtained from the decomposition of a 0.784 gram sample of silver trioxynitrate. Full stop. What is the percentage yield of the reaction? Use the equation this. All right, so look up, please. Look up. First things first, we said before you do any calculation, your first task, ensure that the chemical equation is balanced. This man here is not balanced. So how do you balance this? Please help me, please. Help me balance it, please. Check. Help me balance, please. Who is done? Tell me what you have, please. 2 here. So 2 here becomes 2 of silver. I will add 2 here. 2 of silver. It becomes 2 of nitrogen. 2 times 1. I'll add 2 here. 2 of nitrogen. It becomes 2 times 3. 6 of oxygen. 2 times 2, 4 plus 2, 6. It's now balanced. Look at your question. It says the decomposition of silver trioxynitrate. It makes sense. This is a decomposition reaction. All right. Next up, let's get molar ratio. 2 is to 2 is to 2 is to 1. So I have this. Please note something, please. Please note something, please. When we define actual yield, theoretical yield, percentage yield, there is something I didn't tell you. So note it now. Note, please. Actual yield is the mass. Actual yield is the mass of the metal or the element, better still. Actual yield is the mass of the element as given in the question. Actual yield is the mass of the element as given in the question. Mass of the element as given in the question. So look up, please. If I look at this question here, it means that my actual yield is equal to, please check, which particular element. Now listen, I said in every question, don't narrow your mind down to 2 things. So I have 4 here, 1, 2, 3, 4. Please check which one and which one was mentioned. Silver and what again there? silver nitrate. All right. So observe, they didn't mention this one, they didn't mention this, just mention these two. So I'm working with these two. Now look up, please. I'm asked to find, listen up, I'm asked to find the percentage yield. So first things first, actual yield. I said actual yield is simply equal to mass of the element in the question. Between these two there, the required element is what there? Silver. So the mass of silver becomes the actual yield. Don't forget, actual yield equal to mass of element as given in the question. Please check your question, please. What's the mass of silver there? 0.443 gram. All right, so this is my actual yield. Now listen, what is theoretical yield? Listen, let me tell you how it works. Leave all the whole grammar there. Listen, leave all the grammars there, please. Listen, how does this thing work? It's just what we've done before. It's just name formality. It's something we've done before. What we did before was that we converted mass to mole, did a mole manipulation, got the mole, converted mole to mass, as we did before. So when it comes to whether it's theoretical, don't stress. Do the same process. So here's the idea. In this case, the actual yield is this, because I said actual is always equal to the mass of the element there. So two things. They'll give you a mass of the elements in the question. That's your actual yield. For your theoretical yield, you are expected to calculate the mass of that same element in the question. That's all. The element here was silver. So my task here is simple. I want to get the mass of silver. That's all. When I get the mass of silver, it might not be this one here. It might not be this one here. So my task is simple. Look for a way to get the mass of silver. How do I get that? I said in every question, you will narrow your mind to two. In this question, your mind was narrowed down to silver nitrate and silver. From balanced equation of reaction, 2 moles of this will react with what there? 2 moles of this. Check. Were you given the mole of silver nitrate or the mass of silver nitrate? Check. So you know what to do, Nabi? Convert the mass to what there? Molar mass. To mole, please. To mole. So I'm given mass of silver nitrate is equal to how many? 784 gram. Convert this mass to mole. How? We know that mole is equal to what there? Mass all over what there? Molar mass. So my task would be get the molar mass of this compound. That's the task. I hate when plane passes here. Comment, we've given you this. So it's not as if the roof wants to fall. Usually whenever plane is passed, I'll just wait for it to pass first. And I'll edit this part out of the video. Oh well. Alright. So we have to get the molar mass of silver nitrate. Alright. Let's get molar mass. Molar mass of silver nitrate. That's equal to, this one is how many there? 108. So I'm giving 108 plus nitrogen, how many? 14. Plus oxygen, how many? 16 times 3. So that's equal to 108 plus 14. Plus how many there? 48. Alright, please sum this, what do you have? So 170 gram per mole. I've gotten molar mass of this. So hence, the mole of silver nitrate NO3 is equal to mass. So we said mole of silver nitrate is equal to mass of silver nitrate as given is this one here. 0.784 all over molar mass of silver nitrate as calculated is 170. Please give me value. 4.6. No, please don't do times as this. No, we don't do that in chemistry. 0.00. Give me that 0. Please don't give me times 10 to the power what? Please make sure you count the zeros correctly. What do you have? 0.0046 what there? Mole. So look up, please. Look up, please. So it means that, look up, please. It means that we've now gotten the mole of silver nitrate as 0.0046. Of course, we'll call this X. You know how we say it. Let the what? Mole of silver that will react with 0.006 mole of silver nitrate be X. And then hence we have this as usual. Okay. If you're here, take down please. Let the number of moles of silver, that's Ag, let the number of moles of silver, that's Ag, that will react with 0.0064 mole of silver nitrate be X. Hence, AgNO3, Ag. So from balanced chemical equation, 2 to 2. So 2 of these will give you 2 of this. Okay. Next up, they gave us this mass. We converted this mass to mole with all of this, and we got this mole. So it becomes 0.0046. It's equal to X. Let's cross multiply this and this. 2x is equal to this and this. 2 times 0.0046. Get X how? Divide here by 2. Divide here by 2. This cancels this. X is equal to this cancels this. 0.0046 mole of silver. I said the actual yield is the mass of the element as given in the question, which is this. The theoretical yield is the mass of that same element as calculated. So hence, if I've gotten the mole of this, my task will now be changes to mass. Let's get the mass of this. We know that mole is equal to mass all over molar mass. To get mass, simply multiply mole by molar mass. I'm trying to save time. To get mass, simply multiply mole by molar mass. So it means that mass, the mass of Ag, that's silver, is equal to mole of silver times molar mass of silver. And that's equal to the mole of silver is, what is it? This one here. 0.0046 times the molar mass of silver. That's this one here. What you have here? 108. Please multiply this, please. What's the mass of silver? So, mass of silver is equal to 0.4968 gram. This value, I said the mass of the element as calculated is equal to what? The theoretical yield. So therefore, the theoretical yield is equal to 0.4968 gram. So you have this, please. Therefore, the theoretical yield is equal to 0.4968 gram. Mass of the element as calculated is theoretical yield. Mass of the element as given is actual yield. We are asked to find percentage yield. Shouldn't be a problem. Actual over theoretical times 100%. We are asked to find percentage yield, they said percentage yield is equal to actual yield all over theoretical yield times 100%. Actual is how many? Please check again, please. I've cleaned it. 0.443 all over theoretical 0.4968 times 100%. Please punch this. What do you have? 89.17%. So it is this simple, please. It is this simple, please. All right, so this is how you solve this question, please. All right. Yes, what's that? Yes. In your test, they usually give you, but I would beg you, don't wait for them. Propane C3H8 undergoes combustion to give you carbon dioxide and water. Balance it on your own. Check your question. Let's try this question on limiting and excess reagent. It says, how many moles of propane will be left unreacted when 20 moles of propane are treated with 30 moles of oxygen based on the reaction this? So you have options 20 moles as A, 10 moles as B, 14 moles as C, and 3 moles as D. Let's get this done. So look up, please. Look up, please. This one here is a balanced equation. Molar ratio 1:5:3:4. I said in every question, they will point your attention to two things. Please check. In that question, what and what was specified? All right, so propane and oxygen, look up, please, becomes propane C3H8 and oxygen O2. From balanced chemical equation, 1 mole of this will react with 5 mole of this. Now listen, here's where it becomes tricky. Look up, please. Here's where it becomes tricky. Look at your question carefully. Listen. How many moles of propane will be left what there? We defined limiting reagent and excess reagent. Limiting reagent is the one that is first used up. Excess is the one that is left. Please check. Of course, these are my reagents because they're reactants. Between these two, propane and oxygen, which one do you think is limiting and which do you think is excess? Please check. Propane is what? Limiting is the one that is first used up. Excess is the one that is remaining. Listen to the question. It says, how many moles of what are left for there? So propane will still be remaining. It will be left on there. So it becomes what there? Excess reagent. That's it. When something is excess, what does it mean? More than needed. More than needed. We said excess reagent is the reactant that is what? Remaining after the limiting has been exhausted. In this question, they mentioned propane and oxygen. Which of them is limiting? Which of them is excess? And listen to your question. It says, how many moles of propane are left unreacted? The one left unreacted is what there? Your excess. That means if I combine propane and oxygen, oxygen will finish up and propane will be what there? Left unreacted. So this one becomes what there? The excess reagent. Here's my shortcut. Pick out the limiting reagent and work with it. Call the mole of the excess as unknown. Please. Take down. Just write down. Take down. Take down. Take down. For questions of this nature, if you're here now, for questions of this nature, first identify the limiting and excess reagent. For questions of this nature, first identify the limiting and excess reagents. Work with the limit, full stop, then continue. Work with the limiting reagents and assume the excess reagent to be X. Hold on. Work with the limiting reagent and assume the number of moles of the excess reagent to be X. Work with the limiting reagent and assume the number of moles of the excess reagent to be X. So please check which of them is limiting, please. Huh? Oxygen. So I said we work with oxygen, assume what there, propane to be what there, X. So take that, please. Let the number of moles of propane, let the number of moles of propane, let the number of moles of propane let the number of moles of propane that will react with, please check for your limiting reagent, how many moles given there? Check how many? Good. Let the number of moles of propane that will react with 30 moles of oxygen be X. Let the number of moles of propane that will react with oxygen be X. Hence, so back to this becomes X, this becomes 30. Please know why. So I said, please work with the limiting, assume the excess to be X. Which of them is the excess? The excess is simply the one that is left unreacted. And they said propane was left unreacted. Let's get X, please. What's X here? Cross multiply this times this, 5 times X is equal to 30 times 1, that's 30. To get X, divide here by 5, divide here by 5. X is equal to what there? 6 moles of propane, C3H8. That's all you're solving, please. That's all you're solving. Just do small inference and we're done. So take down, please. Hence, only 6 moles of propane is required to react with 30 moles of oxygen. Hence, only 6 moles of propane is required to react with 30 moles of oxygen. Full stop. Please check how many moles of propane was given in the question. Since 20 moles of propane was given, or use the word is available, fine. Since 20 moles of propane was given or is available, comma, the number of moles of propane left unreacted is, so it's just a simple comma, the number of moles of propane left unreacted is, so let me use a simple concept to explain. I said since 20 moles of propane was given, comma, hence the number of moles of propane left unreacted is, so look up please, look up. I'm given 20 moles of propane. I only use 6, as you can see here. How many is left? That's all. It's equal to 20, which was given, minus, I only needed 6. That's equal to what there? 14 moles of, please, 14 was which option? So that's it. That's how you solve this question. So it's easy. It's just always make sure that your excess is x. Work with limiting. When you're done, you have your answer. Compare this answer with what was given. I'm working with only 6. I was given 20. What's remaining? 20 minus 6. That's 14. So that's how we solve this question, please. Any question, please?